Hey Honors Physics, this is a quick video that really is going to just help you finish off the key idea of Newton's third law. Newton's third law is certainly underappreciated in the sense that it's very easy. The force of object A pushing on B is always equal to the force of B pushing on A, but in the opposite direction. So the vectors are opposites of each other. So A pushes on B, B pushes back on A. So in this scenario, right, it's pretty easy. This hand is pushing on the wall, and so we would show the hand pushing on the wall. Now the wall is experiencing a force that's to the right, right? The hand is pushing into it. So that's how you would show the force of the hand on the wall. But then the wall pushes back on the hand, and the hand is attached to the person. So what we can see visually is that we have two different objects, the wall and then the hand, and the forces are equal and opposite. Now, this is a little bit of a silly scenario, but these two people are playing on rolling office chairs. And there's the pusher-offer, and then there's the person who's kind of stationary. So the pusher's force is equal and opposite to the other. So the pusher experiences pushes on this person's knees. So the other person, that is this person, let's call that O, other, they're going to experience a force to the right. But because this person's feet are firmly on the carpeting or the floor, the pusher is going to experience kind of a rebounding force. And the pusher, the pair is the pusher and the other person. So there always has to be two nouns and equal and opposite forces. Okay, now this one's a little bit maybe weird because you've never thought of it this way. So we have a planet, and this is the planet we live on, and this is you. So you and Earth. Okay, so what does Earth do to you? What force does it exert? And we all know that's the force of gravity, and it's toward the center of the Earth, downward. But the Earth experiences the exact same force in the opposite direction. So it's an equal and opposite force of gravity. Gravity is actually a force pair. The large mass in this case causes you to accelerate at negative 9.8. But because the mass of the Earth is so small, when you pull on it, the acceleration is so infinitely tiny that you can't measure it. Large masses experience tiny accelerations. And in fact, you will never have you will not cause, that is, a significant acceleration of the Earth. Okay, this one's the weirdest one. So we've got an inflated balloon. It's been tied off in a knot in the bottom. Now, we all know that there's air molecules bouncing around in here, and they're colliding with the wall. So the air molecules are pushing on the balloon in which direction? Well, they're pushing out on the balloon, right? And it's pretty much uniform in all directions. So this would be maybe an applied force, or FA. And then the balloon does what to the air molecules? Well, it kind of collapses inward. But we never draw our arrows in on the free body diagram. So when the wall out here, kind of this corner, pushes inward, what it's actually doing is pushing the air molecules kind of down and to the left. And then this upper corner pushes the air molecules down and to the right, and this lower left corner pushes up like this. And this fourth little kind of quadrant pushes on the air molecules kind of up and to the left. And the net result is that it's actually essentially the same free body diagram. This is the balloon being pushed outward by the air molecules. Here are the air molecules. Now it looks like the air molecules are being pushed outward too, but let's make sure we're clear on this. It's this rubber or latex surface that's pushing back in, but because we never show arrows in, essentially that's the same as an arrow out on these molecules. Not out of the balloon, just in the upper left direction. Okay, so you're going to try the bottom of page 11 with some common, actually, these are all ways to move yourself, to propel yourself. A fish, a bird, or a person operating a car. So fish swimming through water, what is the force, action, and reaction force pairs? Well, the fish uses its fins to push water backwards. Okay, it may not be straight backwards, it may be diagonal, but there's definitely a backwards push. And then the fish experiences a forward force, and that's exerted by the water, right? Oops. And that's pushing the fish forward. And that's usually called like a thrust force. Airplanes experience the same thing. The engines push air molecules back out the rear end of the engine, and the engines push forward. So hopefully I kept that pretty short. You're going to try the bottom of these, and you can check on Canvas.